Hello dear students, welcome to Pen and Paper Chemistry. As we continue with our learning journey towards aldehydes and ketones, the preparation and properties. This is part 3 in the series wherein we are dealing with the preparation of aldehydes and ketones, and I've already shared this flowchart. In today's lesson, we will be taking up the preparation of aldehydes and ketones from alkynes. So let's get started. The rules of the game: you need to have your pen and paper or notebook with you in order to take down notes for offline reference. When we talk about the preparation from alkynes, the simple method that we use is hydration in the presence of dilute H2SO4 and mercuric sulfate. So we have over here simple addition reaction, and let's get started. So we will add the hydrogen across the triple bond and OH. So H and OH. So we will have over here CH double bond COH. Now I am writing just a skeletal equation. Later on we are going to take specific examples, as you can see on your screen. So we'll have dilute H2SO4. Now this particular compound is the enolic form. So where does the word enol come from? The en comes from the double bond here, and ol comes from the alcoholic group. So this is the enolic form of the compound. Now what happens here is the hydrogen from here has a tendency to go on from the OH group. It will have a tendency to shift here, and we will have CH and CH, and the double bond will come here. Now I'm trying to make it sound simple. It is actually not how it happens. I'll explain the details later. So when we've got the enolic form, now if you see the other form here, if you see, you'll get a ketonic group if the group attached over here is a carbonyl, is an alkyl group. So this is what we will call as the keto form of the same compound. So we have the enolic form and we will have the ketonic form. The two tend to be in equilibrium, but that equilibrium lies more towards the keto side because of its higher stability. So what we'll do is we will again show it by a reversible arrow, but our arrow is pointing more towards the right hand side, that is the ketonic side, right? Now I have shown the internal transfer over here. It's not so simple. When you see the mechanism, you need to take the hydrogen ion from the solution into consideration in order to show this shift. But for your level, the level that we are talking about right now, I think this should be sufficient, right? And this phenomena is what we call as keto-enol tautomerism. It's like resonance. But in the case of resonance, what happens is it's the electrons which move from one place to the other. I hope you are familiar with the concept of resonance, right? So it is the electron movement which takes place, whereas the atoms remain in one place. Whereas in the case of tautomerism, what will happen is the atoms, they are shifting position within the molecule. So our keto form is more stable, and that is what gives us the ketone, right? So would you like to draw or complete the reaction, the example 1 yourself now, step by step? Let's get started. So we've got what is the starting compound that we've got over here? Yes, it's a 2-carbon compound. It's ethyne. Ethyne, you add water across it. What are the reagents that you're going to take over here? Please complete the equation. Trust me, unless you write, you will always find yourself struggling in organic chemistry. It is very essential for you to write the reactions in order to understand them completely. So I'll have over here CH2 double bond CHOH, right? Again, how will you show? Goes here. So this changes into CH3CHO, and we get the first product over here, which is ethanol or acetaldehyde. Right? Now, can I prepare HCHO by this method? Can we prepare this compound by this method? Think over. No, we cannot, because if you see, we are adding across a double bond. Double bond means the first starting compound would be ethyne or acetylene only. Whereas when I talk about HCHO, it's a one carbon compound. That is why if you notice the flow chart that I have given you, here I have put a strike through over HCHO. This is a hint, meaning to say that by this method we cannot prepare HCHO, right? Okay, so let's get back to the equation. Second one, oh, already written. That's superb, lovely. So we will have over here CH3C. Did you write CH double bond CHOH? Did you write like that? Think. If you've written like that, then I would advise you to think about it, and you have to think about an important rule that we learned in our previous videos. What rule are we talking about over here? Yes, we are talking about Markovnikov rule, according to which this product will be wrong. Why? What does the Markovnikov rule say? It says that the positive part of the adding reagent has to go to the carbon bearing more number of hydrogen atoms in an unsaturated linkage, right? So this is how it's going to be. So let's continue. No worries if you made a mistake, very good, because now this will remain embedded in your mind and you will not do the same mistake in the examinations, right? And that's what we are more worried about right now. So CH3COH double bond CH2, and then the internal shift, and we will have CH3C double bond O single bond CH3, and we have the product here, propanone or propan 2-one, which is also commonly called as acetone. Have you heard about acetone? Where is acetone used? Can you, before I come back with the next video, would you like to do some research and let me know what are the uses of acetone? You can post it in the comment section. That will also give me encouragement to continue with the lessons. The next method of preparation is from alcohols. Now, alcohols is one topic which we covered. The last topic that we covered was alcohols only, and there were two ways that you can do it. That is oxidation and dehydrogenation. Both mean the same thing, but the reagent that we are using in each one of them is different, and I have shared this with you in the flow chart as well. Now, as you can see, from alcohols we are converting them to aldehydes and ketones by oxidation using oxidizing agents. Yes, potassium acidified potassium dichromate, acidified potassium permanganate, chromic oxide, the H2SO4, PCC. What is that? Does it remind you of something? We've done this in the topic of alcohols. Dehydrogenation using copper at 573 Kelvin. Now, I am expecting you to write these reactions. Also, if you remember, we said that when we use any of these oxidizing agents, I'll keep my flowchart on the right. Yes, it helps me to plan my next reaction. Now, when we use oxidizing agents, if you remember, we said that the alcohols get converted to aldehydes, and then aldehydes get converted into carboxylic acids. This oxidation was very, very easy with strong oxidizing agents, even weak oxidizing agents for that matter. But what we are concerned with at present is the conversion only up till aldehydes. We don't want this reaction to take place. So how do we go about it? So I'm taking a generic example over here, RCH2OH on oxidation. What aldehyde will it give you? RCHO, and this on oxidation will give you RCOOH, right? Now, as I said, we don't want this reaction to take place. So what do we do in order to stop the reaction at stage 1 itself? So let's suppose that the boiling point of the aldehyde is T Kelvin. So what do is we distill off. We keep the temperature of the reaction mixture a little above T Kelvin. So distill off the aldehyde from the reaction mixture before it gets oxidized. Right, that's the trick. Distill off the aldehyde from the reaction mixture before it gets oxidized. Therefore, the temperature is maintained slightly above the boiling point of the aldehyde, right? So that's the trick for conducting or converting alcohols to aldehydes. So tell me, what alcohol will you use in order to form HCHO? What alcohol will you use in order to form CH3CHO? Can we form ketones by this method? What are the challenges you face in forming ketones? Have you written the answer to my questions? Okay, did you pause the video? Okay, so we will have CH3OH, that is methanol, getting converted to methanol on oxidation at a temperature a little above the boiling point of methanol. What is that? You can find it out for me. CH3CH2OH on oxidation gives you CH3CHO. What about preparing ketones? Yes, for preparing ketones, you will need a secondary alcohol. So you notice over here, these are primary alcohols. So primary alcohols are giving us aldehydes, while secondary alcohols on oxidation with strong oxidizing agents will give us ketones. So you notice over here, what is the word I used? Yes, you need strong oxidizing agents in order to bring about the oxidation of secondary alcohols. And what about tertiary alcohols? Tertiary alcohols, yes, they give you even lower ketones. They don't give you the ketones with the same number of carbon atoms. You see over here, a secondary alcohol, a 2-degree alcohol. You remember these terms here? So 1, 2, 3, 3 carbon atoms. Your product also has 1, 2, 3. The number of carbon atoms remains the same. But if I carry out this oxidation for a tertiary alcohol, go ahead. So what will happen? What is the product that you will get? Yes, you will get a ketone with lower number of carbon atoms. This is here. You notice 1, 2, 3 and 4. But here your product is 1, 2 and 3. Right? Those are some of the points that you need to remember, and they have been depicted in the chart on alcohols as well. I have listed it again here for you. Primary alcohols get oxidized to aldehydes, which get further oxidized to carboxylic acids. Secondary alcohols to ketones, and tertiary alcohols to ketones with lesser number of carbon atoms. Now, if I want to stop the reaction to the aldehyde stage, there is another option for me. We use something which is called as PCC. P for pyridinium, C for chloro, C for chromate. So pyridinium, C5H5N is pyridine. Pyridinium, so C5H5NH, chlorochromate in an anhydrous medium. So we don't want to use water over here. We use solvents like dichloromethane. What is the advantage of this method? Controlled oxidation. So the reaction, it's a mild oxidizing agent. So what will happen is oxidation will stop at the aldehyde stage and will not go up to the carboxylic acids. Okay, now your turn to write the reactions for dehydrogenation. What is dehydrogenation? A removal of hydrogen, one and the same thing, but here we use it with the help of a catalyst, that is copper at 573 Kelvin. Got it? 300 degrees Celsius. Am I right there? Now, what will a primary alcohol give you? What will a secondary alcohol give you? Well done. If you are able to answer these, that means you are moving on the right track. If you are not able to, then you need to seriously revise alcohols, please. So primary alcohols give you aldehydes, secondary alcohols give you ketones, and what about tertiary alcohol? Do they give you ketones with lesser number of carbon atoms? No, they give us alkenes here. So I cannot use this reaction to dehydrogenate tertiary alcohols in order to obtain aldehydes and ketones. Yes, I can bring about their dehydrogenation, but I don't get carbonyl compounds. So go ahead, write the reaction. CH3OH, copper, 573 Kelvin. Please make sure that you are honest with yourself and there is sincere learning which will happen over here. The more you write, the better it is for you. I could have easily cut short this video and just given you, skeletal equations and left it for you to do. Doesn't serve the purpose. Please go ahead, write the products. I'll give you the products before I end this video, but I want you to pause it and write it. Okay, here are the products. Please tally. If you've got them right, you definitely need to give yourself a little smiley there and take a break before you continue with more reactions. Too much of chemistry in one go actually gets tiring. Also notice in a lot of places we will not complete the reaction. We are not writing the side products. These are skeletal equations and quite acceptable when it comes to organic chemistry. So it's fine if you are leaving it like this, right? So we've covered the preparation from all of the left hand side reactions. We have to now move on to the right one. Remember, these are all preparations because you can see the arrows pointing towards aldehydes and ketones and not the other way around. Before I come back with the next video, why don't you try writing these reactions and then probably you may just tally your answers and that will give you the confidence as well to handle organic chemistry yourself, and that is what the whole motive of this channel is. So preparation from acid chloride, nitriles, esters, the reagents are given to you. Don't worry if you are not able to. We are going to take them up in the next video. So stay tuned, stay connected, stay healthy and stay happy. See you soon.